we can use the Bayes theorem for screening tests. So if you know the sensitivity, specificity, and the prevalence of the disease, you can find the predictive value positive and predictive value negative. Okay, very useful theorem. So we know what is the predictive value positive. Probability of getting the patient will have disease condition. The test is positive. That is, a selected individual will actually have the disease whom already tested positive. Some individuals already tested positive. What is the probability? The selected individual will actually have the disease. Okay, so we know from the Bayes theorem, that is, if I want to find the conditional probability that the selected person will actually disease free from those individual already tested positive. This conditional probability. So we know from the Bayes theorem to calculate some probability from the previous experience, from the prior probability of condition, we can find this conditional probability. So conditional probability is so according to Bayes theorem, we can write probability that is opposite. The test is positive, condition the person have the actual disease. This is nothing but the sensitivity. Okay, we know that probability the test will be positive, condition the individuals actually have the disease. Okay, then you have to multiply by probability this condition, probability of D. Probability D nothing but the prevalence rate. Okay, that is the person actually suffering from the disease. That is called prevalence rate. We know that. And what will be the denominator? Will come this same thing will come. That is the first part we did. That will come same thing plus. That is the probability. Here test is positive is a common thing. So probability test of positive, that is somebody do not have the disease, which is nothing but the false positive. We know that probability that the test will be positive, but the individuals actually do not have the disease. This is called false. That is called false positive rate, or that is nothing but the 1 minus specificity. We did it, but if you know, just remember. And the Bayes theorem, we can use it and multiply the probability of D minus, that is 1 minus prevalence rate. Prevalence rate is the probability the individual suffering from the disease. So P will be P minus P, probability of D minus will be probability that individuals are not suffering from the disease. Okay, this is the Bayes theorem we can use. And if you want to write, you can write simplification, simplify this. So sensitive, as I told, sensitivity probability, if you want to know that the selected individual actually have the disease condition, the individuals from the who's already tested positive. So we can find sensitivity, 1 disease prevalence, same thing will come plus 1 minus specificity. I told the false positive, also known as 1 minus, we get from 1 minus specificity. There's probability of D minus, nothing but the 1 minus disease prevalence. Okay, this way, if you know the sensitivity, prevalence rate, or specificity, that easily we can found the predicted value positive. That is the probability selected individual will actually have the disease whom already tested positive. So this is we can do by Bayes theorem. Similarly, we can use the Bayes theorem to predictive value negative. That is the selected individual will be disease free, no disease, normal person, but already tested also negative from the. So I have to select a individual, that individual will be disease free, condition that the individual selected from those individuals who have already identified as negative. So this is the called predicted value negative. The probability of that individual will be selected will be disease free condition that individual already tested negative. So so you can write the Bayes theorem, probability dt minus condition d minus, that is nothing but the specificity of the test. That is the test is negative, condition the individual has not have no disease. Okay, this is the specific, and probability D minus, you know, 1 minus prevalence rate. Similarly, the denominator with the first one and nothing but the probability T minus condition D plus, that is the false that is nothing but the 1 minus specificity, sensitivity, that is called false negative. Their tests give the negative result, but actually the persons is suffering from the disease. This is called false negative, nothing but 1 minus in sensitivity we can find, and probability of disease, that is nothing but the prevalence rate. So this is, if you know the if you know the specificity and the prevalence rate, and if you know the sensitivity, that is a false negative, that is false negative result, that is, then you can find the predicted value negative, which is nothing but the probability of selected individual will be disease free condition that the individual already tested negative. So in this way we can use the Bayes theorem for the screening test. So little bit critical, just do some practice and remember the other predicted value, what is the d plus d minus and the condition law. It is very easy, just you need to do some practice, don't be scared, do some practice and follow the rule. You can do so lot of way. Confusion matrix you can use. So if you don't have the confusion matrix, that the contingency table, also you can use the Bayes theorem to find the other things. Okay.
Let us go through an example where we can use Bayes theorem for screening tests. If you go through the example properly, it is given that in the population, there are 10% have the fracture. It is also given that somebody tested positive. Also, they have the fracture, that is 70%, which is sensitivity. And other thing is given, somebody tested positive, but they have no fracture, that is 20%. Okay. So if you write down in terms of probability, that is probability somebody have the fracture, which is 10%, nothing but 0.1, and also given somebody tested positive, also have the fracture 70%, that is will be 0.7. And third one, which is given somebody tested positive, but they have no fracture, that is T plus condition D minus 0.2, which is 20%. So what is the first question? What is the proportion positive test? When follow up, they actually be found to have fracture. That is, somebody have fracture. Also, they will be tested positive. So this is the question. If we write down the question like this, so we can write down in terms of Bayes theorem like this, as we learned before. Somebody will have the fracture, also will be tested positive. We can write down like this and putting all the values in the formula, we'll get 0.28. That is 28% of the population will have fracture, also will be tested. They have the fracture, tested positive. Okay. For the second question, somebody actually don't have the fracture, also will be tested negative. Okay. That is also a Bayes theorem we can write down. And I have give some hints. Please try it yourself. Also, you can do this problem using, if you can generate confusion matrix from the given data, also we can get the result. Good luck. Do more practice. It will be more easier.